Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to predict whether or not your substance is going to precipitate, or if a substance is going to precipitate, by using your Q and your Ksp, by comparing your Q and your Ksp. So what you need to do first is given the problem here, so let's look at these two problems here. So the first problem is you're mixing two salts together. So you have a separate salt solution of PbNO32 of lead 2 nitrate, and then you've got another solution of sodium bromide. You mix them together, and then when it's mixed up, you get a solution that has 0.0150 molar PbNO32 and a 0.00350 molar NaBr together in the mixture. And you want to know if something precipitates. So what you need to do first is figure out what the cross products are going to be, right? So you take the ions and you switch them together. So I always do inside and outside. So the inside ones go together. So you get sodium nitrate as a possible product. And then you got lead and bromine. So the outside ones go together. And you got lead, PbBr2. And so you look at these and you see, okay, is either of these soluble? If it's not soluble, if they are soluble, then they're not going to form a precipitate. So and you got to go to the rules, the solubility table, solubility rules. And so if you're looking at the solubility rules, you'll know that sodium products are soluble. Nitrate products are all soluble. So this is soluble. So this is not going to precipitate. Well, how about this? Well, this is does have this is not soluble. It does have a Ksp, so we gotta look up the Ksp value, and the Ksp is 4.67. So Ksp is equal to 4.67 times 10 to the negative 6. So negative 6. So now what we want to do is we want to figure out what the quotient, the reaction quotient is, just like we did with regard to any equilibrium problem, to see which way it was going to go for the Le Chatelier's principle, right? So with regard to Q, the expression for Q is the exact same expression for Ksp, but we're using what the present concentrations are to find the quotient. So here Q is going to be equal to, and again, if we write the equation, the dissolution equation, it's going to be PbBr2 solid goes to Pb2 plus aqueous plus, and we got 2 bromine, so it's 2 Br minus. So then the quotient is going to be Q is equal to the concentrations of these two to their stoichiometric powers. So this is going to be Pb2 plus. It's got a coefficient 1 here, so it's the power of 1, multiplied by the concentration of bromine, Br minus. It's got a 2 coefficient, so it's to the power of 2. And then you're going to plug in your amounts here. So here you got the concentration of Pb, which is 0.0150. So that's going to be, if we put that in there, 0.0150. And then the concentration of this here. So we have 0.00350. squared. And then we calculate that, and we get, let's see, 1.84. So this is 1.84 times 10 to the negative, I want to say 7, yes, negative 7. So here we have Q. This is what we have for Q. Here is the Ksp. So here, Q is less than Ksp. So because Q is less than the Ksp, there's not going to be any precipitation. So this is not going to precipitate. So no precipitate is going to form. Okay. Now what about this concentration here? What about this? Well, in this case, the situation is we heated up both of the solutions before mixing them. So we heat them up, raise the concentration, we mix them together, and now these are the concentrations of our salts mixed together. So let's see if there's a precipitate there. So we do the exact same thing. It's the same species. Since we're mixing these together, it's the same species. So any sodium nitrate is going to be soluble, so we don't need to worry about that. So it's back to Pb Br2. And again, the Ksp, Ksp is equal to 4.67 times 10 to the negative 6. And so we're going to figure out Q this time. So Q again is the same expression up here. Q is equal to the lead to ion concentration multiplied by the Br minus concentration squared. And now we're going to plug in these values here. So that's going to be equal to 0.0600 multiplied by 0.0158 squared. And then we calculate that. And so we get 1.49 or 1.5. We get 1.5 times, or 1.50 times 10 to the negative 5. So that's our Q value. So now we look at the Q value, and here we see that Q, the quotient, is greater than the Ksp. So now we will have a precipitate. So the PbBr, the lead 2 bromide, will precipitate. So that's how you can predict whether or not you're going to have a precipitation or not by comparing Q and the Ksp. I hope this is helpful. I hope you found this video interesting. If you like my videos, please like, share, subscribe, hit the notification bell, and leave a comment in the comment section. Thanks for joining me, and I'll see you next time.